Good morning, everyone. Let's get started with our warm up of the day. I have three questions for you as a review of last week. In the Zoom chat, I want you to answer as many of these as you can, as you remember. The three questions here are representative of Newton's three laws. The first question I have is, what is inertia? The second question I have is, what does it mean to have a net force? And last but not least, the third question I have for you is to give an example of an action and reaction force. So once again, we have three questions here for you to answer. What is inertia? What does it mean to have a net force? And give an example of an action-reaction force. So we'll take about another 3 or 4 minutes for you to try to remember some of these. If you are not sure, you can always look at your notes to try to jog your own memories. What is inertia? What does it mean to have a net force? Give an example of an action-reaction force. These three ideas are very important. They serve as a foundation, a cornerstone, if you will, for physics. Each one of these concepts is very important mathematically and conceptually. We will do a lot of problems regarding the three. The first law is not something that is super computational, but it is helpful to understand how objects respond to forces. The second question is extremely important. Um, Second question is extremely important. It's probably the one that we will do the most. The third question is also important. But it's harder to, the third one is also extremely important. It's probably the hardest one to visualize. But we will look at this quite a bit as well. A lot of forces in nature are due to, or a lot of motion in nature or in the world is due to action-reaction forces. So take another 2 minutes or so for you to think about what these three things are. You have a bunch of good examples so far. I really like reading everyone's examples. I think they're very creative. I also like how people word your answers. I mean, how to word your definitions and stuff. I think sometimes I can give you a pretty technical definition, and having a more colloquial or understandable definition is very helpful as well. So I like what everyone has so far. We have a few different answers. We're going to take 1 more minute for people to jog your members before I will sort of do a very quick review. Sorry, very quick review of these three things, these three principles, these three laws. So let's talk about these three things. So first off, what is inertia? So inertia is like a property of matter. You don't really measure inertia. It's just like a principle. The key idea behind inertia, it's just a property, a principle of matter, of objects to resist any sort of changes to its motion. So you don't really measure it once again. It's just like if I had an object on a table, if it's at rest, it wants to stay at rest. And if it's moving, it wants to stay moving without any changes to its direction or speed. So it's just a property, a principle that things just don't want to change what they're doing. They are I'm trying to think of a metaphor. It's like a it's like a really stubborn like first grader who's like, no, they just don't want to change what they're doing. That's really what inertia is. Your objects or your matter is stubborn and they don't want to change what they're doing. What does it mean to have a net force? A net force is something that the best way to think about it is you have all of these forces acting on objects that are being applied in different directions in different magnitudes. And you might have one force coming from the left and one force coming from the right and one force up and one force down. And once you sort of add and subtract all of your forces, a net force is when after you subtract and add all of the forces, there is an overall non-zero force in one direction. The key idea here is that each one of these individual forces is not a net force. These are just individual forces. A net force is like it's the net word net means you after you subtract and add everything, the overall force is non-zero. So that's what it means to have a net force. A distinction I want you to make is once again that the individual forces are not a net force. The net force is the sum of forces. Last but not least, give an example of an action-reaction forces. We have a bunch of good ones so far. I think the pushing off the side of a pool is really good because when you push off the wall pushes back onto you, and that's why you accelerate forward. A ball hitting a stationary ball, it's a good one too. It's like when you're playing pool, when you hit a ball, right? The ball hits the first ball and the second ball like sort of bounces back. Another good example is throwing a ball at a wall. If you play wall ball when you're a kid, when you hit the ball, the ball hits the wall and then it comes back out. Pushing off water underwater, once again, jumping is a good example. It's sort of like pushing off a wall when you're underwater and throwing a rock at a window. When you throw a rock at a window, right, the rock puts pressure on the window, puts force on the window, and the window breaks. But the rock will sort of get deflected as a result, and that's partially because the window applies a force onto the rock. So those are all good examples of action-reaction forces. So we will sort of continue our examination of these. Today we will be focusing the most on maybe Newton's second law. I wouldn't say we're necessarily like focusing on the law itself, but we are looking at a little bit of the principles behind it today. The only thing we're doing today is a force. The force is a force data analysis on Canvas. I will actually link it to the chat right now. Will be, I would say, this is going to be a change of pace from what we usually do. It's not computation at all. Instead, it is very much written based, argumentation based. You're going to be doing a little bit of data analysis that I've written out instructions for. You're going to analyze the data and you're going to try to use the data to support your arguments. The key things we're examining today is we're looking at relationships between quantities. It's in Newton's second law. So in Newton's second law, we have three quantities: force, mass, and acceleration. And we're going to look at the relationships between these so you can fully examine what happens, what causes what correlates with what changes what. And you're going to use the data to try to understand this and try to use the data to support your argumentation. So that's what we're doing today. Instructions are all on the paper, on the sheet, and there are questions for you to answer. So the key thing I want you to think about is using data to support your answers. I will talk about this in 1 second. So the first things, before we talk about that, there are a couple of things that are going to be, I want to talk about due dates. So for Wednesday, you have a California Healthy Kids survey that you are supposed to use due to uh, uh, participation on Wednesday. So I don't have any asynchronous assignments for you. Originally, I was going to do our survey, but since you are actually supposed to do the California Healthy Kids survey, we don't have any asynchronous assignment. I'm just here to remind you that you have to do that instead. Healthy Kids survey. The forest data analysis. I'm tentatively having a rough draft due next Monday, Tuesday. I would say we will have the rest of today to work on it. But that will be it in terms of time wise, I think. So I'm hoping that you'll at least be able to get put together like a rough draft, a bunch of pieces for it before we move on to the new topic of discussion on Thursday, Friday. So we'll try to get as much done today. Last but not least, I'm being observed during the first half of second period on Friday. So I'm being observed like an evaluation. So feel free to pretend that you're really interested in the class and that I'm the greatest teacher of all time. So if you want to try to participate a lot and try to make it seem like you enjoy the class, that would be helpful. But you don't have to. If you're like having
Yes,
some
sir.
fun, you really don't have to. But I'm just here to guilt trip you into pretending that you're really interested. But yeah. So if you just want to summon up your energy for one day, it'll be nice. Pretend like I'm really interested. So that's for this week. Um, so what I want to talk about first is the assignment itself. So the first thing you're going to do is I have a bunch of, so you have the data from your FET that you did last week. Hopefully you finished that. What I also gave you is a set of gravitational data that I collected from my last year class. This data is what we did was we had a bunch of masses. And then we measured the gravitational force on each of one of these masses. And so you're going to use the data set to try to help you determine relationships between quantities. The first thing you're going to do is you're going to sort the data. I have instructions on there. You're going to create a scatter plot. Once again, I give you instructions on there. Then you do a linear regression. A linear regression, if you aren't sure what it is, it's basically like a line of best fit. It basically calculates a slope for your data. And so you're going to use that. And I have instructions for you. You can just put this formula in any random box and it'll just do it for you. And it'll create a linear regression for your thing and it'll give you a slope. You might want to think about what the slope represents, what quantity it represents in Newton's second law. So that's for you to decide. But that's all the data analysis you need to do. Afterwards, you are going to use the data from both the FET and the Google Sheets, whichever one is more relevant or more helpful, to try to answer the following questions. What I'm looking for I have a rubric on the bottom that you can look at. What I'm really looking for are strong claims, strong and accurate claims. In other words, strong and accurate like answers with a good amount of reasoning and evidence behind them. The length of which isn't necessarily the important part. I'm not looking for a bunch of fluff. I'm looking for strong arguments. I know sometimes the natural tendency is to write very verbose things, especially in science. The length isn't necessarily what matters. What matters is that when I'm reading your answer, that I feel convinced, that I feel like you know what you're talking about, and that you're using good evidence to support it. So that way, if I feel like no, I feel like you're incorrect, your evidence can't convince me otherwise. So this is the reason why this is important is because when you answer a question, you're going to be like, okay, I think the mass does this. And so, it may or may not be accurate. The key thing is that you are going to use the data to try to support your point, right? And so I think part of the process, as you are using data to support your point, you may figure out that your initial observation, your initial response doesn't actually fit the data, isn't actually particularly accurate as you examine the data. And so you may end up changing your answer because of that, right? So whatever you answer, your data should support that. So because of this, the idea is you're going to have accurate answers that is backed by the data, and you have reasoning that explains why your data supports your claim. So, this is sort of akin to a CER, but that's not really what I'm not looking for you to write a CER. I'm just looking for you to have, your basic answer, you have some evidence to support it, and you explain why your evidence supports your answer, right? So basically, it's like a little sandwich for it. So that way, it's basically like imagine you're convincing like some crazy Facebook mom or dad or whatever who's like anti-science, and you're using this to try to convince them otherwise, and they can't really argue against it because your data backs it. So that's sort of the key behind this. A bunch of questions for you to answer. Question 5 is meant to be a numerical derivation. So this one, I don't expect you to have really any sort of verbose answers. I just want you to derive Newton's second law in the specific case of gravitational force. So question 5 is not meant to have a word answer. That question 6 is meant to have your data support or refute Newton's second law. It's not enough to just say it holds true or doesn't hold true. You should use data and explain why. Question 7 and 8 are different. I would say questions 4 and 6 are probably more straightforward. Questions 7 and 8 are different because they talk a lot about causation and correlation. We haven't talked a whole lot about it yet, but I'm sure that you have seen this in one way or another. Causation and correlation are two different ideas. Causation means that something, if I do something, it causes something else explicitly, right? So if I push this box, it pushes something else. That is what causation is. And correlation just means like if I do something and that something does something else, right? It's like this. The first thing doesn't actually cause the last thing to do something. It's more of the first thing related to the last thing. So that's what correlation is. And so what you're gonna do is you're gonna look at Newton's law and you're gonna try to determine which of the variables are causally related to another, and which means that if when one of them changes, it explicitly causes a change in the other one, and which ones are just correlated. So if I cause one thing to change, it doesn't explicitly cause the other one to change. It's more of after everything is changed, there's sort of a relationship there. So question 7 is sort of related to that, and you should use evidence to try to support that. And then, based on numerical evidence or sort of evidence based on experimental processes. And then question 8 is sort of similar to that, but you're looking more at a cause and effect. So what are you causing? What does it act on? And what is its effect? And once again, try to use data to support that. So, or at least explain what the phenomenon behind that. So that's what I'm looking for today. And then I have a rubric. If you're sort of unsure what I'm looking for, I have a rubric as well in terms of how I'm going to grade it. So what I'm going to do is I'm going to let you get started. If you have any questions for me, please let me know. We will have the rest of the period to work on this, so try to get as much done as you can. Otherwise, I'm going to let you get started and let me know if you have any questions for me.
Should we make a copy of the gravitational data spreadsheet?
You do not. Yes, you should make a copy of it so you can do your data analysis on it. Yes, you should make a copy of it. Okay, we are out of time here, so yeah. So okay, so I have this tentatively due next Monday, Tuesday. What I want you to do, I want you to submit a rough draft. I'm not gonna grade it Monday, Tuesday, but I want you to submit a rough draft by it, and then we will work to try to improve your rough drafts. So overall, I like where people are. We will pick this up next Monday, Tuesday. As a reminder, your asynchronous thing is the Healthy Kids survey. So your Healthy Kids survey. So that's your participation. I don't even think I'm doing that for you. I think someone else is measuring the participation, or not measuring, giving you participation for that. Other than that, I have office hours weekly, 2:40, 3:40. That's not changed. Other than that, I will see you all on Friday. Sorry, I keep you long. Also, I'm being observed on Friday if you want to be super enthusiastic.
Have a nice.
Last plug. The last plug for myself. Okay, sorry, it's okay. Do you have a question for me?
No, I just said thank you very much.
Okay. Bye-bye, it's okay.
Thank you.
Mr. Who?
Yes, go ahead.
Do we have to turn in our spreadsheet or no?
No. You don't have to turn in the spreadsheet.
All right, thank you. See
Yeah.
ya.
Very good question for you guys. You know, I've been saying this a lot.
Thank you.
Okay.
Mr. Who, I'll answer a lot of questions on Friday. Don't worry.
Okay, cool. That's good. Okay. I appreciate it.
got
I
you.
appreciate it. Then people will actually
100%.
think that I'm a good teacher.
Don't worry, Mr. Who. 100%. Ask me for any of them. I'll answer. I mean, I'm basically a genius, so like I know all of them. I even finished the whole worksheet thing.
Okay. Well, that's good. That's good. I appreciate it. It's good to have one person who doesn't totally hate the class.
No, this class is fun. I actually go into the class and like, wow, like I don't like dread it. Like I wake up and I don't like dread school. Like I dread the next couple classes, but like at least the first one will be okay.
Well, that's good. That's good. And you can always blink if you're being kidnapped.
Yeah. I gotta make sure sometimes. Like I'm enjoying this too much.
Yeah. Well, that's
Okay.
good. That's good. I'm glad you don't totally dread this. For me, that's a huge win. Having people totally not dread this class, I think that's a huge win. I think a neutral opinion, that's good. That's very solid.
Yeah. All right. Thank you.
Okay. See ya. Farewell. Take care, John.
You too.